Welcome back all. Today we're going to go ahead and begin a new chapter. So here we will talk about exceptions in C++. In essence, exceptions represent an efficient mechanism of managing programming errors. They were introduced in C++ 98, and unlike C++, C does not have exceptions, but rather instead it uses global error variables instead. This chapter will also cover standard exceptions, and in order for me to explain what exceptions are and why is it that we actually need them, it is best to take a look at an example and then figure it out from there, just to see why we would need them. So we'll basically write a function, sqrt, which will calculate the square root of some given number. I've already started code blocks here, and it's up and running. So I've also created a new project for this chapter called exceptions. I've decided to skip this part as I trust by now you know how to do that. Okay, so we will need a few things here. The very first one is basically include CMath. Yep, in addition to the iOS stream. And down below, we will go ahead and well, I guess we can create a prototype here and then create the body down below, but since we're going to use one single function, I don't think there is a need for prototyping and then defining it down below. Although if you have more than one function, go ahead and create prototypes and then define them elsewhere. Create the bodies elsewhere. So double sqrt double x. Okay, and so we'll need another double value. We're going to name this variable sRoot. It's going to be std : POW. Now POW basically calculates the power of. It will. Let me just go ahead and put it like this. If this is x, some number x, and this is some number y, what will happen is that it will calculate the x to the power of y. So this will give you a calculation x to the power of y. So we will leave x here, but here we shall type in 0.5. So x to the power of 0.5. And then we shall also go ahead and return sRoot. So return sRoot. There you go. So there are probably simpler ways to actually eliminate a variable from this, but no big deal. You don't actually need to go through all of that at the time being. Let's just go ahead and write the program down below, and you will see how this relates to exceptions in a moment. We're gonna need double num and I don't know, std cout, enter number. I don't know, the user will enter some number of their choosing. std : seeing a lot. You wouldn't believe how many logic errors actually occur due to user input, because a user does not think in the same way that the programmer does. And the programmer, if they enter an integer, they believe that everybody will enter an integer. So a stupid example, of course not, but just a stupid example. And then comes along somebody and types in a float, and that of course creates problems. Now imagine this, but on a more complex scale. Square root equals sqrt, and we're gonna have we shall pass to the function the variable num. So this is calling the function and assigning its return value to the variable square root. So you have a square root, and then this function will basically take the parameter num, and it will return a variable whose value will be stored into this variable. And we're just going to go ahead and do a bit of a printout down below. for our sake so that we have an idea what is going on here. Okay, sqrt, so square root. If there is one thing that I hate doing is basically formatting these printouts, because I've done so much of that, it's hilarious. You might say, oh, well, that's great, you know, you got a lot of practice, etc. No. It's all the printouts are the same to me. It's just formatting it like this, formatting it like that, blah, 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 blah. Because almost every example in these basic things, they have the cout printouts. So square root std and l. There we go. So this program will work perfectly if the user enters positive numbers. So let's just go ahead and run it. So much for running perfectly. Missing a semicolon there. Run it. Okay, I assure you it will run very soon. stdcin not declared. Okay. Okay, come on. Third time's the charm, as they say. Bang. Enter a number. What shall we enter here? Okay, let's say... So as we said, it works very good until the user enters positive numbers. So 1. 1, okay? Let's go ahead and enter like 30. Okay, still works. However, what if the user enters a negative number? For example, I don't know, -9 or whatever. We know that the square root of a negative number does not exist. It is not defined. So in that case, our square root function should in a way or in some way report some sort of an error. And this is where we will use exceptions. C had a global variable ERRNO, so error number, which should be modified by a function and repeatedly checked. Unfortunately, that concept is outdated and is not good enough for most programs today. So our sqrt function should stop the execution if a negative number is passed to it. It shouldn't return anything. It should simply stop the execution by throwing an exception. To throw an exception, we use the keywords throw followed by the actual exception. So let me just go ahead and write some pseudocode here, and I will show you where the problem lies here. So for example, you would just type in throw, basically are throwing an exception. I don't know, negative numbers are not allowed. So there are of course other ways to solve this in this program. It's quite easy, but you don't need to use the exceptions to solve it. However, we will in this particular case just to demonstrate how exceptions work. Negative numbers. Or you can do this. Throw, and then you just give it a number. Or throw, you can do, I don't know, std : domain error. Negative, and then just type in like, I don't know, again, negative numbers are not allowed. Okay. I need a semicolon at the end of each one of these. Sorry about that. It's basically not pseudocode, but it's outside of the main, and this we're not going to take into consideration. Or you can even just do throw std : exception, and then you can just go ahead and copy this entire thing and paste it right here. So now we shall modify our function to throw an exception in case of an invalid parameter. But before we do, let's go ahead and see what happens. And before we see what happens, just take a look at these. These are formats of throwing exceptions. So I will show you how to actually do that in a program, but I just wanted to show you different formats of how this can be, of the syntax, that is. So let's go ahead and delete this, and let's go ahead and build and run this program one more time. And let's go ahead and pass -4. What? Square root of -4 equals nan. Okay, so in a way, the program basically tells us that that something is wrong, but this is not really what we want. We want the program to tell us, hey, whoever you are, basically, let's give us we would like to know what is wrong. Tell me that I should not be allowed to pass a negative number. Okay. How shall we solve this? Well, as I said, you can solve it simply with a printout statement and with a cout and if. However, we don't want to do that here. Here we want to do something different. And basically, it's gonna look very similar to if, because we are going to use if. But in the if, we will use throw as well. So if x is lesser than 0, then I would like you to throw negative number. So just throw an exception that the number is actually negative so that we know that there is a problem. So our problem is now solved. The function will stop with the execution if a negative number is passed to it. All we need to do now is check what does stop executing actually mean. We will see that in the main function. So basically don't need any of this. We can leave it, but there really isn't that much that much of a need. We can just pass the number ourselves in the program, so we don't have to bother with the input. So it's a little bit boring. And okay, so you can do a printout down below, but let's go ahead and do this, like -10. Let's just write -10 here. Okay, so build and run. What now? What? Error. Num was not declared in the scope. Okay. Yeah, I've just deleted it, so obviously. Just didn't notice it. Okay, there we go. No. Give me build and run. What do we got? What do we got? Exceptions.exe. Exceptions.exe has stopped working. A problem caused the program to stop working correctly. Windows will close the program and notify you if a solution is available. By the way, has anybody ever, if you've seen this message before when any of your programs crashed, did Windows actually ever notify you that a problem to the solution has been found? I mean, if you have been notified that a solution has been found, please give me some feedback. Tell me of your experience. Okay, so it says terminate cold after throwing an instance of char const. This application has requested the runtime to terminate. So keep in mind, this application has requested the runtime to terminate. Keywords, application has requested. So to terminate it in an unusual way, please contact the application support team for more information. Well, welcome to the application support team. How can I be of assistance? Close the program. Okay, so press any key to continue, and that's going to be the end of that. So basically, the program should crash, as it did. The function threw an exception, but nobody caught it. So we have an exception, but nobody's catching it. Now that is a good thing. If we pass an invalid parameter to the function, the program will at least crash. I mean, it won't run. So we'll have some sort of an error that we can see. So it won't be like a logic error on our end. It will be something to do with the machine. That the machine basically gives us some sort of a feedback and it crashes the program. It doesn't run. The worst sort of errors are programmer errors that are actually not reported or detected by the machine. So the program runs, it just doesn't do what it is supposed to do. Anyway, we've just seen how we've started this program and then it crashed and that's it, it aborted. Now that we know how to throw an exception, we need to learn how to catch it and control the program execution. So catch and control. This is called exception handling. Exception handling works as follows. The code that is supposed to throw an exception is placed in a special block, basically. It's called try block. The block of code will begin executing, and if the execution is successful, the program will continue working as was planned. But the try block is immediately followed by another block of code which is executed just in case the try block was not successful. The second block of code is called catch. So the catch block, it requires specification of an exception. So of an exception type, it basically is expecting. The pseudocode for this is not very complicated. It's actually quite simple. So we can write it onto the screen, and then we can see what we can do with it. So you would have something like this. Try, and I don't know, right here. Try executing the code. So there will be some sort of code execution here that would get, the program would attempt to execute this code. But down below, it's going to be catch. And this would be type of exception. Never mind the highlighting now with the keywords. Forget about that. That's just me. That's just me using these keywords as a part of regular text. So this is basically exception thrown, type of exception, and then exception thrown. So the try block has failed. Now we're going into the catch phase. We're catching the exception. Okay, so this would handle the program in case try was not successful, exception thrown. So if try is successful, the catch block will not execute, so it will just remain there. However, if an exception is thrown, we enter the catch block in which we basically catch the exception and we gain a measure of control over the program, unlike here where we just threw an exception and the program crashed. Okay, so let's go ahead and see how that works in reality. We are going to go ahead and make a few modifications to our program here. So first of all, we are going to remove this from the function. Well, not, come on, don't do this to me. And we're not going to need the pseudocode down below. We're gonna delete that as well. And now we're gonna write just a bit of a longer code here to see how we can actually construct the try catch block and place code in it and see how it behaves. However, I'm really running short on time. It takes a bit of a time for me to actually explain these things. So I'll just continue in the part 2 of this particular tutorial.